Alright, I'm back from the other thing that I needed to do. So anyway, getting back to here. So one way to do this, I just figured this out, is to use a spreadsheet. So we'll go ahead and start up a spreadsheet. And what I'm going to do is to copy. Okay, we are going to copy this code. Okay, so we'll do a Control A, Control C, and copy this code into column A here. There we go. And this is a lot easier to deal with because now we can, let me just double click this to make it as wide as necessary. This is a lot easier because now we can go ahead and use column B to represent the C code. So now we have the C code on one side and then the assembly code on the other side by side, so it's easy to read. So in this case, the halt is really the return 0 of main. So we can just say return 0 of main, and that's the end of main here. So we put a close curly brace here. And then in the other subroutine, in subroutine F, okay, so this is all basically the return in a C function. Okay, so that marks the end of the C subroutine. Okay, all right, and just to make this even more clear, especially with this return here, what we can do is we can merge the cells so that we know which cells correspond to a single return statement in C. Okay, so that's good. And we also have identified the call. So right now we have the call of the subroutine F. So we'll do exactly the same thing here. So this is basically a call to subroutine F with no parameters. So we'll go ahead and merge everything from start of call to end of call, and go to Format, go to Merge Cells, and merge all of them. Okay, so now we have two done. And let's see what is left to do. Over here we have the starting point of main. So when you see a label definition, it designates either the entry point of a subroutine or a point where a conditional branch or loop is going to branch to. So labels are definitely important. Label definitions are important. So main in this case is the entry point of the main subroutine, which is not really useful in our context because we don't really have anything to return to. But nonetheless, in C code, this is corresponding to the starting point of the main subroutine. So we'll definitely make it important here. Alright, so now we have load A with X, LDI A X2, A is loaded with X, B is loaded with 2, so we want to look up what is X. So when we scroll down, or where is X? We do not have an X here. Let me see. That's probably because I do not have an X. I forgot to copy that last line of the original program. Okay, so let's go ahead and add it back. So there's an X at the end here, and that is a byte 0. It's a global variable, basically. So in this case, we are going to put forgot we're here. So what we're doing here is basically we're putting the address, the label X is representing the address of the variable X. So we are storing the address of X into register A. And if you prefer to comment here, we can say register A is the label X. And here we have register B being the value of 2. So over here we are dereferencing A, which is the same thing as X, and we are basically storing a value of 2 over there. So these three lines combined is really just saying X equals to 2 in regular C. Okay, so we go ahead and do another merge. There we go. So main is pretty much done at this point. Now it's time to go to F. We already know F is a subroutine because we identified that here as a subroutine. So we say, okay, F is a subroutine, and let's not worry about whether it's returning anything or what kind of parameter it is expecting. We'll just let it be for now. Okay, until we find out that we are using registers in a particular way, that's a safe assumption. And because the first thing we do is to destroy or to overwrite the value of A, that pretty much tells me that F has no parameters, or if it does, it has more than 2 parameters. So I'm not too concerned about the parameter things at this point, and what I'll do is to say A equals X again. And once again, in this case, X is representing the address of the byte that has a label X corresponding to it. So A is storing an address to a certain location in RAM. And over here, we say B is whatever A is pointing to, which is basically X. So in other words, this is the same thing as saying, B has the value of global variable X. So there's no direct representation in C because C does not have access to the registers directly. And then over here we have A being 0. So when we compare, we are actually just comparing X to 0. Okay, so this is comparing X to 0, or the value of X to 0, not the address of X to 0. So we are basically doing something like this, and remember we need double equal here to represent equality check. Okay, or we're comparing. I should be a little bit more clear here. We don't know what we are doing here. We know it is some kind of comparison, but until we look at the conditional branch, we don't know which comparison we are using specifically here. Okay, the next statement is a go return. Okay, whatever label is being stored in A, and we know that A is used in the conditional branches, so we kind of know that there's a go to involved here. So we know there's a go to in C that is going to the label go return. So we specify go return all the way down here. So in C, you can also define labels, just like the same way that we define label here. Alright. So the most important part here is now to look at, when are we going to go return? Okay, so this is saying, if the Z flag is set, we go to go return. If that doesn't happen, then we have another chance to go return, which is when the L flag is set. When the L flag is set, it's saying X is less than 0. Okay, because when we say CMPBA, we are representing the condition here. So whatever this relationship is actually going to be put into here. So because of the Z, we know there's an equal involved in the comparison. And then there's a L, so we also know there is a less than involved here. So basically, when X is less than or equal to 0, we want to go to the go return label. So now we have a much more complete picture of what we are doing here. So starting from here all the way to here is basically saying if X is less than or equal to 0, we want to go return. Okay, so let me get rid of this and merge the cells that are corresponding to that one single statement in C, which is this bunch here. So let's go ahead and merge these particular cells, and now we have one single C statement. Okay, and we'll make this as wide as necessary so we can see the entire thing. Alright, so let's take a look at these instructions here. We are putting a value, okay, there we go. So in here we are putting a value of 1 into register A, and we are subtracting from register B. Now register B is still holding the value from before, because when the conditional branch does not happen, then we are still retaining the value of B, which is the value of local variable X. Okay, so here we are just doing B minus equal to A. And B at this point is the value of the variable X. And the next thing we do is we are loading the value of the label x into a. So a equals x, and remember a is now an address, and then we store b back in that location. So this basically is saying, okay, so in the assembly code, this is what we are doing. We are dereferencing a as a pointer and then store the value of b into that location. But when you look at what this is really doing in the context of a C program in terms of the global variable x, this is actually what we're doing. We are basically saying, okay, x gets x minus 1. Okay, to make this valid syntax, we put a semicolon here. So now we look at these 4 lines and then say they are related, they are the same. So we go to merge cells, merge all. Okay, and then this is the last part where we say a equals 1. And remember what register D is? Register D is a stack pointer. And so we are, once again, we are doing some kind of stack operation, which is kind of important. So we want to see what we are really going to store into the stack pointer. So at this point, we'll just say the stack pointer is decreased by 1. So we want to say, SP decrements. And then this one is reusing register A to store the value of the label return address. And what we do is we store that to the stack. Okay, so star D equals A. But what this really means is we store return address 1 to the stack. Now that is important because this is where it is. So when we store an address on the stack, most, if not all of the time, it is a return address to set up a call. So that tells me that these instructions are really setting up for a call. Okay, and to confirm that, we can see that we are putting the label f into register A, and then we are jumping to that location. So that means, together these 2 instructions is a go to f. But when you look at all the instructions from here all the way down here, including this label return address 1, that's actually just call f. Okay, it's just calling f again. So now we actually have another call to f, and that is corresponding to these lines in the original assembly code. Go to format, merge cells, and merge all of these. There we go. And I think we have just about everything already. And in this case, x is a unsigned. Well, okay, so we don't know yet. Okay, so we know it's a byte long kind of thing, but is it signed or is it unsigned? We actually do know whether it's signed or unsigned, and that has to do with the choice of using JL instead of JC when we do the conditional branch. So when we go back to an earlier point, which is right here, you can see that we have a JL instead of a JC. The use of the L flag indicates that we are treating the result of the comparison as the result of a signed comparison. So that's why we kind of know that x is signed. So over here we can say it's a signed integer of 8-bit because it's a byte long and it's a global variable. So there we go. So these 2 lines combined is declaring a global variable x. So once again, we merge the cells like that. Okay. Let's see, do we have anything left? Yes, we do. Okay, because right now we have something that has a unstructured conditional statement, because we see that this is a if statement with a go to, which works in C but is not structured. In the final exam, I will be asking you to write the structured code. So what that means is you have to look at these lines. Okay, look at these lines over here, and basically say, okay, can we convert this into a structured C code? Okay, and when you look at the actual meaning of these things, it's basically saying if x is less than or equal to 0, do not subtract 1 from x and do not call f again. So that can translate to this is how we get to the else branch. Even though the else branch has nothing to do with this, it is still the else branch, which means when the condition is false, we go there. So when we look at this, then we go like, okay, can we turn this into a structured conditional statement where goTo is not used and there's no need for this label here? So the way to do this is to look at this and invert the condition to say that if x is greater than if x is greater than 0, we perform these two statements. So keep these guys exactly the same as before. Okay. And this is marking the end of the conditional statement. So that means we just put a close curly brace here, because this is the continuation point when x is greater than 0 is false. Because when x is greater than or 0 is false, it means exactly the same thing when x is less than or equal to 0 is true. So this way, we now have a structured conditional statement. And I'm going to do the merge here, just so that we know exactly what line is corresponding to what line. So these are all together. These are all together. And these are all together as well. Okay. Merge. There we go. Okay. And the rest of the program is already done, so we can now actually see the entire program. I am going to start a new sheet just so that we can combine everything, so that we can see what is going on with this program. That is. It may be better off if I just use a text editor to type it in. Okay, so that's what I'm going to do. Because the usual lazy trick won't work in this case. I cannot just do a autofill and expect this to work, because these merged cells do not get copied correctly when I just do the autofill. Okay, so I'm just going to copy the entire thing here. So we have int main open curly brace which is from row 2, and then the next one is x equals 2, which is from these 3 rows, and then the next one is a call to f, okay, which is from this whole bunch of rows here, and then we have a return 0 corresponding to the halt instruction, and that's the end of the main subroutine. Scrolling down a little bit, we look at f here. So the next thing we want to know is f returning anything? If f as a subroutine is returning anything, it's going to return it through register A. But you can see that register A is not storing anything useful. It is simply used, the last use in the subroutine is a return address. So that means f is not returning anything useful in this case. So in C, the way we say this is it's returning a void. So we now copy the rest of this. And we want to copy the structured conditional statement, not the unstructured one. Or, as I call it in class, it is the flattened code. So column B is corresponding to the flattened code in C, and then column C is representing the actual structure code. So now we have if x is greater than 0, open curly brace, and then x gets x minus 1. If you prefer x minus x, it works as well. And then we scroll down a little bit. We have f, the call to f, and then we have the closed curly brace corresponding to the conditional statement. And then we scroll down a little more, and we have the usual return statement. Okay, the return statement is obviously not needed, because every C subroutine by the end of that subroutine is going to return, but it doesn't hurt to specify here. This is actually valid in C and C++ as well. So now we have the decompiled program. Okay, so this process is a little bit lengthy, because I keep, try to explain everything as we encounter the instructions. But that's basically, how it works. Okay. So you might want to write down, some instructions for yourselves. The first thing is, if you recall, how we did this. I personally like to start with the jump instructions and the conditional branch instructions. And also the label that we use for branching. In other words, you kind of look at these two lines as one single construct, because all together it's just saying that we want to continue execution at label f. And then the same thing over here. We look at these three lines as one single construct, which is going to the label or continuing execution at the label go return if the comparison result is equal to or less than. Okay, so we focus on the branches first, and this one is also a branch, so it's also significant. So I personally would look at the branches first, conditional or unconditional. And once you identify a branch, then what you do is to say, okay, what is the context of this branch? In other words, what is leading up to the branch itself? Now, in this case, what is leading up to the branch itself is also involving some stack operations. Okay, so when we look at these four instructions together, they are basically just storing a return address onto the stack. So given that particular context, that we're storing a return address on the stack and then continuing execution at a label, that basically spells out a single subroutine call, which is represented over here in the C code. In the other context, we have conditional branches. Okay, so when we have conditional branches like these three, because I consider the LDI a part of the conditional branch because that determines where we are going when the conditional branch does happen. So in this particular context, the compare right before is also important because the flags are set mostly by the compare instruction. Or we utilize the flags most when they're after the compare instruction. So we have to decide what they're comparing. So we have to look at register B and figure out what register B has, which is from here. But then register B is just really grabbing whatever A is pointing to. So we go up one more to find out. Oh, okay. So we are just register B of the compare instruction is really just the variable X, okay, the value of variable X. And then it's being compared against A, and A is set to a 0 right before the compare instruction. So this is really comparing the value of variable X to 0. So together, we then have this idea that so when X is less than or equal to 0, we go to the label go return, which is all the way down here. Okay, so we identify all of these important stuff, which is part of the control flow part of the program. And once we figure those out, okay, the rest of the program are mostly just assignment statements. And assignment statements are not as challenging in some way because you really just have to follow what is happening to each register. Like in this case, A has a value of 1, and B retaining the value from before is the value of global variable X. So that means we are really just subtracting 1 from the value of X, but it's not being stored back into X yet because everything is now being done in the registers. So to store that back into X, we have these two instructions to store everything back into X. So now we can look at these four instructions together and say that okay, that's an assignment statement, which is X gets X minus 1. These instructions actually resembles these instructions a lot because all of these are really just setting up for another call. So the analysis of these assembly code and converting that into a single call in C is identical to what we have just done a little bit earlier. Okay. And then with the conditional branch instruction, you also kind of need to know where the then branch ends, and that is indicated by go return. So go return is the end of the then branch, which optionally may have an else statement. Now, if there is an else statement here, there will be unconditional branch to jump over the else branch. So that's also something that you can look into. And I have a phone call coming in. I'm gonna ignore that for now. Okay. So that basically is how we decompile a program. As you might remember, this is a program that we have done in the class already. This is how I introduced recursion in the class. So let me just rename this file. It's already in a shared folder. So I'll call this assemble example 1. So now you can actually see the whole process kind of more step by step. So decompile this Oh, this is not disassemble. I got it wrong. I got the name wrong here. It's decompile, not disassemble. Decompile example 1, which goes along with decompile this. Okay, so these two are kind of together. Yeah, you don't want to do disassembling. That is very mechanical and very boring in many ways, and I'm not going to ask those questions in the final exam. All right, so I hope you find this useful. And if you want to practice with more decompiling code, you want to look at some of the other sample programs that we have used before. So you go to shared and you go to subroutines. Let me see if this is a good one to use. Okay. Oh, this is definitely not a good one to use because that's exactly the program that I have illustrated a little bit earlier. So definitely not this one. Recursion, that's the same code that we have just dealt with. We have done some more in class, so you might want to refer to the examples in class. And then the other ones, the other ones are over here. Are those in subroutines? No, they're in examples. So we did a few examples already. We have the simple return. Okay, so when you look at the simple return and you look at the code that is actually generated, okay, well, it's not actually simple anymore because of this, but you can look at the C code, which is here, and then you look at the assembly code, which is here. So what you want to do is to kind of look at how each statement in C is translated into assembly code, because once you know how it is translated in one direction, you can go the opposite direction. Okay, and personally, I would focus on the JMP instructions because they are the most useful and indicative instructions as far as control flow is concerned, because they identify either a call, a return, or some kind of control structure, and all of those are important in a C program. And so once you have identified those particular constructs, a call, a return, or a conditional branch, the rest are mostly just assignment statements, or a part of an expression. So I'm kind of running out of time here. So what I'll do when I do have time is to go over this example. So what I'll do is I'm going to copy and paste all this assembly code without the comments into a spreadsheet, and then we go through the same exercise and try to figure out what this program is really doing. Okay, so hopefully in that process, what you can do to get out of this one is to write down not just the instructions to deal with this exact example, but write down some general instruction for yourself, so that you can have a general approach of reversing the assembly code of a program back into the C source code. Okay, so I'm going to stop this recording now and upload it so that you can have this available for studying. All right, and I'll come back and do some more recording later on.